Hello, in this video let's discuss another question. You are given an undirected tree rooted at node 0 with 10 nodes from 0 to n minus 1. The tree is represented by 2D integer array edges of length n minus 1, where edges of I is ui, vi indicates an edge between nodes ui and vi. You are also given an integer nums of length n, where nums of I represents the value at node I and an integer k. You may perform inversion operations on a subset of nodes subject to the following rules. Subtree inversion operation. When you invert a node, every value in its subtree rooted at that node is multiplied by minus 1. And the distance constraint on inversions. You may only invert a node if it is sufficiently far from any other inverted node in one of its ancestors. Specifically, if you invert two nodes A and B such that one is an ancestor of other, then the distance between them must be at least k. Return the maximum possible sum of the tree's node values after applying any number of operations with the above condition satisfied. The constraints are the number of nodes is up to 1if, and the values are from minus 1if to 1if, and k is up to 50. So the question is saying that we can do any number of inversion operations, but only if the condition is satisfied. And what is the condition? For example, if we are trying to invert a node, the nearest ancestor of it should be at least distance k from it. Only then we can invert the present node, else we cannot invert. In this way we can do any number of operations, and by doing an operation, every node in its subtree will be multiplied by minus 1, the value. And finally, we have to return the maximum possible sum that we can achieve by doing any number of operations. So firstly, how can we start? So the first thing that comes into our mind is we want the maximum sum. So let's do the operation at nodes if the value is negative, because we want a maximum value. So if we do the operation at negative, it will become positive and our sum will increase. But the values of nodes can change, and also if we do operation at node x, we can't do operation for some set of nodes. For example, let's say this is the root node. These are two examples. For example, this is the root node, and then this value is negative. So what if we try to do the operation? So if we try to do operation, this will become 3, this will become minus 2, this will become 7. So the values will dynamically change. So if the tree is constant and only if the root value, like only the node value is multiplying minus 1, then it is very easy because the things are independent. But here, when we do an operation on a node, some set of nodes, we can't do the operation. So the things are dependent and we cannot decide simply based on the maximum value. So we can't go greedy in this case. So now if we are at node x, then what are the operations that we can do? What are the possibilities we have? The first thing is do the operation here. So firstly, if we check if we can do the operation. If yes, then do the operation, else we can't do operation. And secondly, don't do operation. So these are the two possibilities we have. So we can do the operation if something satisfies, and no need to do operation. These two are the things we have. And now, firstly, when can we do operation? So we discussed that we can do the operation only if the latest ancestor where the operation is done is at least distance k from the node x. For example, if this is the node x and this is the ancestor where the operation is done, so the distance must be at least k. The number of edges must be at least k between these both. Only then we can do. So simply we can understand that this is dp because the things are dependent and we have to track something, right? For example, at every node we also have two possibilities, we can do or we cannot do. So simply this kind of knapsack, and let's try to think in terms of dp, because we got the dp, we cannot do greedy here. Next we got that is just dp, and what are the states that we have to maintain? The first thing is node, obviously, because we want at which node we are at, and also we have to find based on the node, right? So dp of node is mandatory, and then the k is up to 50 because it is given that the distance is up to only 50. So it is obvious that we have to maintain another parameter also, because wantedly it is less, so we can maintain this also. So now what is dp of node and distance? So this is the maximum value in the subtree rotated node, and distance is this distance where previous operation is done. So this is the distance of the nearest ancestor where the operation is done, and dp of node of distance returns the answer in its subtree, in the node subtree rotated node, and the distance of the nearest ancestor where the operation is done is distance. So this is the dp that we got. That's it. So let's do dry run and let's get if we are missing anything. So now we can write the transitions. So function of node comma distance. Firstly, don't do the operation. So if we are not doing operation at the node, then what will happen? Nothing will happen. So this node value is the value of node because it is given. Plus there are many children. So we are not doing the operation, right? So we are not doing the operation. The distance will simply increase. For example, the last node where we have done the operation is 3 from the node. So from the child, what will be the distance? It will be simply 1 plus distance, right? Because this one and this distance. So simply the value plus function of child 1 comma distance plus 1, function of child 2 plus distance plus 1, and so on. And now next we can do operation only if the distance is more than or equal to k, right? Because we are maintaining a parameter. So now we can very simply check if the distance is more than or equal to k, only then we can do operation. And if distance is more than or equal to k, then we can do operation. And if we do the operation, then what is the final answer? The answer is minus of value of node because we are doing an operation here. So the value will be multiplied by minus 1. So minus value of node plus. So now we are doing operation here, right? So when we are doing operation here, for all the children nodes of this one, what will be distance? It will be 1 because its parent, the operation is done for its parent. So the nearest ancestor where the operation done is parent itself. So the distance is 1. So for every child, the new distance will be 1. The old distance will be overridden because we have done the operation here. So this is what we want for the children, right? So minus value of node plus function of child 1 comma 1 and so on. So now distance plus 1. So here distance plus 1, but here 1. So now the next thing to observe is there a difference in storing the difference if it is k or k plus 10 or k plus 20? No, right? Because we can do operation if the distance is more than or equal to k, whether that can be k or k plus 10 or k plus 20 and so on. The only thing is that should be at least k. That can be any number greater than k, but that must be at least k. So no need to store k plus 10 or k plus 20, right? Because the space complexity will increase. Because for storing k plus 20, we have to get big sized array. So big sized array, no need here, right? So simply we can just store maximum k because we don't care if the distance is more than k. By how much? We just want whether if it is more than or equal to k or not. So every time when we are increasing distance plus 1, by without simply adding distance plus 1, we can simply maintain minimum of distance plus 1 and k, because even if that is more than k, we don't care because we'll do operation anyways if that is more than or equal to k. So simply we can store minimum of distance plus 1 comma k every time when we are not doing operation. And when we are doing operation, there is no need to take a, right? Because that will be 1, which will be always less than k. So no need to store more than values of k. So simply the value of node plus function of child 1 and minimum of distance plus 1 and k. And also as we discussed, the distance will be k, right? Because there will not be more than k. So simply we can just replace this by distance is equal to k. So if distance is equal to k, then we are doing operation. And then we can continue. Now that is fine. So we are doing operation at node, that is fine. But we have to add the fact for every child node by multiplying the value by minus 1 because we are doing operation. So we have to multiply by minus 1 for every node. So should we do manually? So the next thing is how to multiply all the nodes by minus 1 in the present chapter if we do operation at a node. And secondly, are we sure that the value of the present node is value of node? Because here when we are not doing operation, we simply use the value of node. And when we are not when we are doing operation, we are using minus, and when we are not doing, we are simply using value of node. But are we sure that the value of present node is value of node? Because this might have changed because of the before operations, right? Because for example, if we are at root node and this is the child node, for example, we are doing the operation at parent node at root. So the values are 3 and 4, and for example, we are doing operation here. And when we are doing operation, the values of both will become minus 4, right? And in the function what we are passing, we are simply passing function of the node. Let's assume this is 0 and this is 1. So what we are passing only function of 1 comma 1 because 1 is the node and 1 is the distance because this is the nearest ancestor where we have done the operation. So we are passing this, but we are not getting this information, right? Because it is already flipped. The value is already minus 4, but we are not using that. And when we are when we are doing the DP for this, we are not using -4, we are using 4. This is completely wrong, right? Because we are not using the updated value, we are simply using the initial value, which is very wrong. So there is something wrong in this. We can't do, because the values can change. But here we are simply using value and minus value blindly. But this is not correct. So we have two questions left. The first one is how to multiply all the nodes in its subtree by -1. Because if we do manually, it will be of n square. Because for every node, we have to do DFS or BFS in all its subtree, and we have to multiply by -1. So that is not possible. So this is the first one to track. And then the second thing is, we are, so maybe if only TLE comes, then that is fine, at least half may pass. But here the values itself are wrong, so the answer is also wrong. So we can't do this. So at least let's try to find how to change this. And now how to do, let's come to first one. So how to manually, without manually update all the values. So why we have to do operation, right? So why we have to do operation? Because the reason we have to do this is to get the updated value for the present node we are at, right? So why we have to multiply by -1? Because we have to get the correct value of all the nodes, right? So that is the main goal. So without manually multiplying, is there any other way to get what is the updated value for the present node? So before that, let's check one thing. For example, if a node, for example, if this node is affected by only one time, is affected only once, then what will be final value? It will be simply minus value, right? Because it's affected only once, so it will be multiplied by only once by -1. So the value is minus value. And what if the node is affected twice? So if the node is affected twice, what is the final value? The final value will be value itself. Why? Because after applying the first operation, it will become minus value, and after applying second operation, it will become plus value, because we have to multiply by -1 again. So finally the value will be value, and for third time it will become minus value, and so on. So from this we got that we just want to know if the present node is flipped even or odd times. So only this is required. So if that is flipped odd times, then the final value will be minus value, and when we are doing the operation, like if that is done even times, then there is no change. And when is this, and when is the count? For example, we have to write, and now we are at this node. So when we are doing at this node, we will get some function of this node value and the distance. So when we are computing the function of this, then we have to check what is the number of times till now the value flipped. Maybe in future, if we do the operation here, the value may change. But when we are doing the operation here, when we are finding the two cases, we have to get the number of times it flipped because of its ancestors, right? For example, we done operation in 2 times in its ancestors, then the final value will be value only, because it is even times. And again we may do the operation here, but we don't care. We only want the correct value when we are finding the don't take and take values at the current node, right? Because here when we are doing the operation at node, we want the correct value. Maybe this may be flipped after, we don't care. But when we are doing the operation, when we are doing the don't care, take and don't take, then we want the correct value. And how can we get the correct value then? We can get correct value then if we know the number of times it flipped because of its ancestors. So hope you got this. So what we want to track here, we want to track how many times it flipped also. So let's check try run, and then we can discuss how can you do that. So for example, this is the initial tree and we are at root. So if we decide that we are doing operation at root, so let's assume k is equal to 0. So this is just wrong, because k is at least 1, I think. Yeah, k is at least 1. But let's assume k is equal to 0 just for understanding. Oh, k is equal to 1, fine. So this is fine. So any two nodes can be flipped in this case. Maybe parent or child and anything. So let's assume that we are doing operation for the root node. If we do the operation for root node, every value will be multiplied by -1. So -1, -1, -1, all values will be -1. Red indicates that this is the affected values when we do the operation at root. And now let's assume we came here. And when we reach it here, let's assume that we are doing operation again here. So if we are doing operation here, then -1 again here and -1 again here, right? So finally this will become 1 and this will become 1. So what it means? So are you able to observe anything? This is simple, right? Because when we are doing the operation at parent node, it will propagate to every of its child node, right? Every of its child node. There may be any number of nodes, but when we are doing operation here, every value will become -1, will be multiplied by -1, whether it can be sub child or any number of children below it. Every node will be multiplied by -1. So here we can simply use some kind of a single value propagating for every node. So initially flip is 0, right? Because at root node we can flip, like it is unflipped. So the flip is 0 because it is flipped even number of times. So the value is 0. So the value is same as before. There is no minus value. So initially flip is 0. So when we are doing flip, we have to send the information to the children also, right? Because for example, if this is flipped, it means that all the children of that also flipped. So when we flip here, we have to send the information that it is flipped for all the children now. Because when we flip, all the values will be updated. So if we have to send that information in the DP, right? Only then the child nodes can get the correct value. So we have to get third parameter of DP also, where it represents the flip value. So now what is the updated DP? So we want updated DP of node, and we have to get flip also. What is the number of times it flipped, even or odd? And the third is distance. So why we want flip it as the parameter? We want this because when we are deciding to do or not do an operation at a node, we have to get the correct value for that node, and we can get this only if we have the information from its ancestors, whether it is flipped once or twice or thrice and so on. So now if we flip here, so if we flip, we initially flip is 0, and when we are flipping this, what is the net number of flips? It is 0 plus 1, right? Or this is 0 XOR 1, because anyways we are storing only 0 or 1. So we can simply XOR this, so that if it is 0 0, it will be 0. If it is 1 1, it is 0. And if it is 0 or 1 or 1 or 0, it will be 1. So it means that for even it will be 0 simply, right? If it is even, if the sum is even, the value is 0. If the sum is odd, the value is 1, which can be simply interpreted as XOR, because 0 0 0 1 1 0. So the sum is 0, right? So XOR is simply sum. So when we have flip as parameter, we can pass flip XOR 1 to the children if we are doing operation. Because we are doing operation, it means that we are increasing the flip. So it means we are increasing the flip. So simply XOR. If we are not doing operation, the same number of flips will go through the child. So simply flip itself. But when we are doing the operation, flip XOR 1 is the ultimate flip count for the children. That may be 0 or 1. If that is thrice, this will be 1, because we only want whether it is done even or odd times. So initially we are doing the flip. So initially it is 0 and we are doing the flip. So what will be the final XOR? It will be 1. So for children, we have to pass that this value is updated once, so that this value finally will be minus value when we are doing operation for that node. So function of 1 comma 1 comma 1. This is node, this is the flip, and this is the distance. Node, flip, distance. Because we done the operation, so we passed 1 comma 1 here. And now let's assume that we are doing the operation for this, like we are doing the state computation for this state, for this dp 3 dp state. Now when we are doing operation again for this state, then what will be the final value? So till now we have done one operation, right? And when we are doing operation at this node, what will be the ultimate flips? It will be 2, which is 0. It means that indirectly we did not do operation, because the values are multiplied by -1 twice, right? So it means we did not do operation simply. So what we can send? We can simply send the node value and 1 XOR 1. This is 0 and this is distance, because we are doing operation here. So distance is 1. So why is this 0? This is 0 because this node is affected twice. One when we did an operation for this, and in second time we did an operation from this. So simply this can be interpreted as 0 because it will be multiplied by twice by -1. So finally it will be 1. So simply we can use XOR and third DP state to know what is the updated final value for the present node when we are doing operation. So hope you got this. So because here it is finally 0 because it is simply -1 into -1, right? So do some examples, then like do some trend, then you can clearly understand why this will work. This will also work because, for example, if the question states that if we do operation here, if it affects only some subset of nodes and not every of its node in the subtree, then this will not work, because this will work based on the fact that if we do operation here, every node in its subtree will be affected. So only then we are able to pass single parameter by updating to its child node. So that will be correct. But if the question states that we can do operation like the nodes will be multiplied by -1 only for some subset of nodes, then this will not work. So now finally let's check the updated code. So we can maintain third parameter also, db of node, flip and distance. So now we can get the correct value of the present node. So if flip is true, it means that flip is an odd number of times, because flip is 1, right? So if the operation is an odd number of times, value is simply value into -1. So this is the updated value, and then we can check if we can do operation or no operation. So if we are doing if we are not doing operation, simply value, which is this value, and then child 1, flip and distance +1 and so on. And if we are doing operation, minus value, because originally it is value, this is this value, and then we are doing operation, so simply minus value, and then function of flip XOR 1 +1 and so on. So finally maximum of all. So simply updating the exchange list and then solve. This is the node, this is the parent, because we can do 3DFS, right? This is -1, and then 0 is the distance, 0 is the flip, because initially any node is unflipped, so flip is 0, and finally distance is k. So now if dp is not -1, it means we already computed, so simply return and find the ultimate. So find the ultimate updated value for the present node. So if flip is true, then current into -1, because if we do an operation odd times, the value will be multiplied by -1. So if flip into -1, and we can do operation only if the distance is equal to k. So if distance is equal to k, then do the operation. So how can you do operation? So simply loop through all the children if it is not parent. So solve it comma I comma flip comma XOR. We discussed, right? So this is the parent, this is the child node, and this is the ultimate flip, because we are doing operation, so then it will be flip XOR 1, and then distance is 1, because we are doing operation here, so for any child node the distance will be 1, and then this is the answer because of the child nodes. And for the present value, what is the value? It is simply minus current, because we done the operation, so current into -1 again, so value minus current, and then we can skip operation anywhere, so there is no any if condition. So simply we'll check if we don't do operation. So minimum distance comma, and then flip, and then answer is equal to max value, and then return answer plus current, because we are not doing operation, so simply this current value will be added in the final answer. If you have any doubts, comment below. See you in the next video.